Good afternoon. Welcome to AP Calculus. That's what the name of the show is. The purpose of the show is to prepare you, the calculus student, the keen math student, the Gaussian math student. First thing I thought of, Gauss, I don't know. Anyway, the point is that it's to prepare you for the AP exam, which is coming up in how many sobering days? 28 days! Get it? Sandra Bullock, sobering, never mind, you have to be a movie buff to understand that. Wow, 4 weeks from the day, it is all over. All over, don't have to know another derivative for at least until you get to college. So we're going to continue doing some questions that might very well be appearing on the AP exam in 28 days. And we have the great Martine from Molina. I got to turn this thing down. That's what I was trying to do. Hold on for a second here. Wait, scream again so I got to make sure it's okay. That's not better. Okay. Hey, Martine.
Mm-hmm.
What's going on?
Oh, nothing.
What type of problem you want?
Your volumes.
Volume.
Yeah.
Let's show a picture of Martine with his
Orange.
boring. You want to see a picture of me?
No. What's that? Oh, the fly.
Bzzz. It's a picture of me. Kevin Gonzalez, a fine BC student at Bride Adams, made that. Okay, volume problem. We're just going to leave your picture up. Let's go back to Martine until I find a volume problem. Okay, here's
Get that thing over there.
what's that? So how did the prep sessions? You've been working in that binder?
Yeah.
All right. That's
Not
what we
really.
like. Not really?
No, we've been busy. We're doing food labs.
What's that?
We'll be doing food labs.
Hey, 28 days, Martine.
Huh?
You can make the Jaguars proud by giving your best shot of doing as much as you can. I know Miss Brzezinski has you loaded with stuff to do, right?
Yeah.
It's great stuff. And this is the key because you know what? In this class, the in calculus, what the thing is that you we know. I mean, we're done with the course. So all we have to do is review, and the more we review, the better off we're going to be, right? Okay.
Well,
What do you want to do
graph
here?
it,
Okay. You want? If we didn't have a graphing calculator, what would you do?
I would set the functions equal. The square root of x plus 1 equals x.
Okay.
Find
And
the
then what would you
intersection.
do?
And then, so square the x.
Okay. So it's x plus 1 is equal x squared. Then what do you do? We got problems because what's going to happen is it's x squared minus x minus 1 equals 0, and that doesn't factor. So I guess that this problem would be a graphing calculator problem because we can't solve this unless we are in Newton's method. What was that? What, Miss?
It's just Carla.
It's just Carla?
Yeah.
Okay, let's take a look at this here.
Okay.
It's awfully fuzzy. Okay.
Whoa.
Okay, let's take a look at it and,
We can't see.
okay. Can you see, oh, well, I haven't typed in anything yet. How about square root of x plus 1? Can you see that okay? Except that
That's a square root? That's a square.
okay. All right, hold on. We're gonna work on the thing here.
Okay, then.
Can you see that or not really?
Yep. Yeah.
All right. Square root of x
Barely.
plus 1 and y equals x. And we'll go zoom 6, even though we just care about the first quadrant.
Whoa, can't see nothing. Oh, there.
That's
it.
better? Okay. So then, hold on, let me get some.
Second cog.
Then what we want to do, so
Trace it.
we're looking for this little region right in here.
Mm-hmm.
We're looking for that point. So let's actually make our window to be a little better. What would our window want to be? If we want this region in here, what do we want to make our window to be?
4. So 4. So 4 will be better because, like, it's... Well, if you want to change the window.
Okay, 0 to 4, and how about 0
Oh,
to...
okay.
We're going to
Oh,
make
we
0
just
to 4, 0 to 4, since we're in the first quadrant. Okay, and where did it go?
You did, right?
What happened? Oh, I guess we didn't. 0 to 4 and 0 to 4. That might be a little better. There's the first graph, and here's the second graph. So we're talking about this region, the first quadrant. So therefore, if we want to find the intersection, we'll go second trace 5. Get as close to the point as you can and press enter 3 times. 1, 2, 3. So we're talking about 1.618, okay? Talking about 1.618.
Okay. So it's
So-
the volume integrating. Okay, to the graph.
So we're talking about this region here, and this is 1.618. So if we revolve it around the x-axis, what are we going to use? What formula?
It's volume equals pi. Oops, sorry. Integrating from 0 to 1.618.
Okay, great.
It's the outer square, which will be just x plus 1
Excellent. It's square root of x plus 1
minus
squared.
the inner.
Oops,
which
not
will be
squared, you're
x
right.
squared.
Minus x squared, right?
Mhm.
And that's pretty easy to do. We would just do that, we just put that in y sub 1, or we could do, in the calculator, we could do the integral of y sub 1 squared minus or y sub 2 squared, or we could just type this whole thing in, right?
Mm-hmm.
Hey, that's a great job. I'm going to give you a harder problem when you call in next time, okay? All right. Jake the snake. What's
Hey,
going on?
Mr. Fleischer.
Let's
How you
We
doing?
haven't shown your picture in a while, Jake. Let's show your
Hey.
picture there.
Oh, okay.
Hey, it's Jake Moore! Hey, we need a little more applause back there. So Jake,
Well, there's only 3 of us, so
hey, but that's okay. 3 is a crowd. And
I guess so.
what type of problem you want, Jake?
Oh, I don't care. Just surprise me.
Surprise you. Okay, you got it. How about let's do the same type of thing, but same region, and let's just set up the integral. We're going to rotate this region about the line y equals 3. So if you recall, we found out that they met, this is y equals x, they met at 1.618. So do you
Okay.
have, what would be this y coordinate?
That's y. Oh, the y coordinate.
Yeah. If they meet at x equals 1.618, what's the y coordinate?
It's the same.
Yeah, it's the same because the graph is y equals x. Okay, that's one of the graphs. So if we want to rotate about the line y equals 3, all right, so what are we going to do?
You're going to do 3 minus the functions, and you're going to have to do the outer radius would be switched this time, and so it's going to be like 1 minus x, like the integration pi.
Okay, so it's
From,
pi from 0 to 1.618.
Oh, you're going to have to change it. No, you're not. No, you're not. Okay.
Do you want me to change it or not?
No, you don't have to change it.
Okay.
You're going to have the outer radius would be 3 minus x. You're going to square that. And the inner radius is going to be 3 minus the square root of x plus 1 quantity squared.
Boy, that's too easy, Jake.
Yeah.
Hey, when you call in, I'll get you a harder problem, okay?
Okay.
And then you do that on, you'd either expand that out
Yeah,
or do it on your
Oh,
calculator.
that'd probably be a calculator problem.
Yeah, it would be a calculator
Yeah,
problem,
because
all right?
yeah, okay.
That's too easy. We're going to challenge you next time, okay, Jake?
Okay.
All right. Who is out there? Sandy Marcone?
That's me.
What, did you see Kevin Gonzalez's picture of me? You guys missed it?
Yeah. Oh, yeah. Yay.
All right. What type of problem you want? Don't say BC. That didn't work out last week.
What about it?
What about, well,
decay.
what about a trig problem for you?
How about not? How about a
Trig?
growth and decay?
What?
Growth and decay. We were doing that today.
Growth and decay. Okay. Growth and decay it is. Hold on. Where'd the extra sheets go here? There they are. Growth and decay. How about this? How about some element has a half-life of
Oh, no.
45 days.
45.
Some radioactive element. 45 days. At what time or at how many days? And how many days does how many days does the element still have about 20% of its original matter? Original, how about we'll put original stuff.
Original stuff.
Yeah, if there's if an element has a half-life of 45 days, and how many days does the element still have 20% of its stuff? Exactly 20% of its stuff.
Okay, well, you know the equation is y is equal to c times e to the kt.
Okay, because we know that the rate that's decaying is proportional to how much is present, so that is excellent. Go.
I guess we can go ahead and start finding C.
Start finding C.
Yeah, well, I know K is 20.
Well, we're never going to find C.
C is 100%. Well, I know that K is 20%.
Okay,
not.
if in 45 days, what has happened?
Well, wouldn't your...
At 45 days, what has happened? When t is equal to 45, what do we know has happened?
So Y is 0.5.
Y is half the original amount. So we know that 1/2 of C, 1/2 of the original amount, when t is 45, Y is 1/2 of the original amount. Did you see that?
Yes.
Okay, so it's 1/2 is equal to e to 45 over k. So natural log of 1/2 is equal to 45k. So k is equal to natural log of 1/2 divided by 45. Okay, so that's what k is. So we're going to rewrite this equation. You follow so far?
Yes, I have.
C e to the natural log of 1/2 divided by 45 times t. Okay, now what do you want to do?
Go ahead and... We didn't know when it's 20%, so put 20% in for Y.
20, just 0.2? 20% of the...
0.2C.
Very good. 0.2c is e to the natural log of 1/2 over 45 times t. And now we're going to solve for t. Now, there's something you can do here. We could simplify this before we do anything. How can we simplify? Well, we don't have to, but we could if
Well,
we want.
E to the natural log is just...
Yeah, but
They
this
can't
is
put-
e to the natural log divided by a number times a number. Let's take a look at this for a second. If we have e to the natural log of 1/2 divided by 45 times t, what we could do is realize this is e to the t over 45 times natural log of 1/2. And how can we make this, how can we simplify this to make it look a little prettier?
Find a common denominator.
Well, no, it's, what do we know about a natural log of b? What do we know about a natural log of b?
Of what?
What do we know about a natural log of b? How can we simplify that?
They divide.
Well, no, the rule is
Oh,
a
you
natural
move the A up to the top?
log of b raised to a. So we could rewrite this to be natural log of 1/2 raised to the t over 45. And now what you have is e to the natural log of u.
And then the natural log of an E cancel out.
Right, so therefore now we could rewrite this to be 1/2 times t to the 45th if we wanted to. So therefore 0.2 is equal to 1/2 times t to the 45th. And how would you solve it from there? It,
Let me see.
Raise both sides to 45 over t.
Do I raise both sides to the 45 over T?
okay, we could do that. It'd be 0.2 raised to the 45 over t is equal to 1/2. But we're sort of back where we started. From here, you're going to have to take the natural log of both sides, or either from here or here. If you take the natural log of both sides, then you're back. Then you could realize natural log of a to the b is 45 over t. Natural log of 0.2 is equal to natural log of 1/2 or 0.5. And now you could divide both sides by natural log of 0.2, multiply both sides by t, and then divide it out. You know, now this is just an algebra problem to solve for t. But in order to do that, you had to take the log of both sides. In this case, we do natural logs.
Okay,
Sort of hard, isn't it?
just a little.
Yeah, have Miss Arthur go through some more problems like that with you, okay?
Okay.
Call back again, Cindy Macon. Hello?
Hello?
Hi, Carla.
Hello.
Hey, let's do more volume stuff with that problem that the great Martine. Since he did a really easy job with that, I have your picture. Then you get a harder problem because he was so easy. Okay. I got you right here, Carla. Where'd
Hold
you
on,
go?
okay. Hey, I can hear you.
Does Ms. Brzezinski have you doing lots of stuff?
Yes.
All right, there she is. Okay.
Shut up, Jeff.
Oh, now that's not nice.
That's the way I treat him. No, I just like.
Okay. Same region that the great Martine had. Okay, but now we want to rotate, this is 1.618. Now we want to rotate about the line x equals 4. Now we want to rotate about the line x equals 4. So what do you do here?
Oh, we're looking for the volume, right?
Looking for the volume, yes.
Okay, it would be volume equals pi integrated from, hold on. From where? Ah!
Okay, so it's from 0 to 1
Oh,
point.
everything's gonna work? Everything has to. Oh, we gotta put everything in terms of y.
Right. We want it because we're taking a billion of these slices. That's a
Okay.
horrible looking slice, but taking it from 0 to 1.68, so we're going to have 1.618. So we're going to have it in terms of y, right?
Mm-hmm.
Okay. So what is the, so talk to me. Tell me what is big R going to be?
Y squared minus 1 equals 6.
Okay, well, you want to solve for y, so
Oh,
we'll
yes.
do that. So
Yeah.
y is equal square root of x plus 1, y squared is equal x plus 1, so x is
Well-
equal to y squared minus 1.
Uh-huh.
Okay.
And
Now
the
what do
other
you want
one
me to
is
do?
y equals 6.
What's that?
No.
Right, and the other one's y equals x.
Uh-huh. Okay, so it's gonna be, yeah, I know. Top line the front of it. Okay. Oh gosh. No.
It's right now.
No, it's 5 minus 5. Yeah, there you go. Okay, it's gonna be x squared.
Huh?
Four.
Oh, no, I don't know what I'm doing. I'm lost.
Okay, the radius, the outside radius is 4 minus this curve, so it'd be 4 minus
Okay. I know. I
y
get it.
squared minus 1. And
The square.
Right,
Oh.
squared. And the inside radius, what would be the inside radius? What is the length of this line right
So it's
here?
gonna be 4 minus x.
Very good, it'd be 4 minus x,
It's
right?
square.
Yeah, it's a hard problem, okay? But actually,
Oh,
we
dy.
yeah, and we haven't wanted in y because it's terms of y. So take a look at that, okay? Take a look at that. Make sure you go over that with the great Miss Brzezinski, okay?
Okay.
Okay, good job, Carla.
Thank you.
The great Wesley Reiser. Reiser? Reiser?
Hi.
How you doing, Reiser?
Blanked out for a second, sorry.
What's that?
Blanked out for a second.
Blanked out? Hey, where's the, I thought you were going to do a theme song for us.
Only when you change the video, that's what I told you last time.
No, it's okay. It's all right. Yeah, talk to, when you call in next time, give them a hard time for not changing the open. It's called the open in TV talk or something.
All right.
Tell them they should change the open.
You have to have the great Jake on there.
The great Jake. That's right. We'll have the great Jake. We're going to film him from college. We're going to, Dallas, there's no expense too great for Dallas. Jake, where's Jake going to school next year? Austin?
UTD.
Well, hey, UTD, we actually can film him. That's we want someone's going far away because we'll just send the film crew. There's a huge budget that they have in this
Well,
department.
Daniel Bravo's going to MIT, so you could go up to Boston.
Well, he's going to MIT. I know that, and that's an amazing thing. And he went for the interview already.
Yeah.
Wow, that's great. He didn't, and that's super.
And he's still actually allowed to go there
That's
after
right.
that.
Because he is an outspoken guy. Okay, Wesley, let's take a look at this problem right here. Write an equation of the line tangent to the graph of y equals cosine 3x at x equals pi over 9. No help from the gallery.
All right. Well, the first thing you need to do is take a derivative to add pi over 9 to determine the slope.
Talk to me.
So first you take the derivative of cosine 3x.
Which is?
It's negative sine of, it's negative 3 sine of x.
Negative 3 sine of
Sine
what?
of 3x. Never.
Okay. No calculator allowed in this problem.
I'm not using it, so now you have to plug in the pi over 9 into that.
Okay. So the slope at 3, y prime of 3, is negative 3 sine of pi over 3. What's sine of pi over 3?
Square root 3 over 2.
Right, so it is negative square root of 3 over 2. And so that's the slope. What's the point at 3?
1/2.
It's cosine of pi over 3, which is equal to 1/2, right?
Yeah.
So what is the equation of the line?
The equation of the line is it's y minus 1/2 equals negative 3 square root 3 over 2 times pi over 9, or x minus pi over 9.
Very good. Excellent, Wesley. Hey, good job. Call in again, okay?
All right.
Great job. Woo! Is this the great Jane Lilly?
Yes, it is.
Like, much more I cannot wish you? Is that the name of the song?
Yeah, I think it is.
Hey, yeah, you were like, seriously, you were fantastic. I got your picture. You were like, you're like, I mean, you know, when you first started singing, I thought that you were lip syncing.
Really?
Yeah, you were really good. Hey, hold on, wait till I zoom in on this again.
That's a
There she
famous-
is! Woo! Really? Yeah, they were asking about this song. The Woodrow Musical, which is absolutely like a professional thing here. She had a solo. Is like promise. I thought they were lip syncing, but you were really. I was really impressed.
Thank you.
Hey, yeah, Jane. Wait, they want you to sing right now. So go ahead and.
What am I supposed to sing?
You're supposed to sing the song.
The song?
Yeah, much more I cannot wish you.
Are you serious?
Yeah, just sing the first couple of bars.
Okay.
Because otherwise people will think I'm lying.
Okay. Velvet, I can wish you for the color of your coat, and fortune smiling all along your way.
All right. Woo! I'll tell you. Those people, that is really, seriously, that's, okay, I'll be quiet. Hey, how are you on the volume stuff?
Okay, I guess.
Are you okay or pretty good on it?
Nah, I'm just okay on that.
Just okay, okay, I gotta give you one of those then.
Okay.
All right, let's do this. Hey, guys, wasn't she really good? I mean, they turned it up. Okay. All right, we're going to use a calculator on this one, okay?
Okay.
So y is equal to e to 2x and y equals e to the 8x. So first thing we're going to, well, you tell me, what are we going to do?
Okay, well, first we can graph the two things.
Okay, so let's do that. Eight x and e, because this is like on the exam every year, these volume stuff.
Right.
Okay. There's 8x. Can you see this okay? I was trying to get the light here.
Yeah, I can kind of see it.
Yeah, it's sort of, if you do zoom 6, it's not very good. Let's make the window to be like from 0 to 3 and the y's from 0 to 10. Let's see if that works out.
Okay.
Okay, so that now we could see. So we're talking about this region right here, and you know how to find these two intersection points?
Yeah.
You do go second trace 5. Second trace 5 and get to the point that you you know, I don't see my little thing, and I see that the y value is 10, so I know I got to press the left arrow to go down,
Right.
and my little thing should be coming. There it is. So press enter 3 times. So one of the boundaries is 1.077, and the other one, second trace 5. It's coming. So it's other one's 1 point.
1.78.
Okay, 1.787, right? Is that right?
Uh,
Okay. Oops.
0.178.
0.178, okay. So we got 0.179, what was the other one?
1.077.
1.077, yeah. Okay, so we're talking about a region, here's 8x, and here was the curve. The curve was below it.
Right.
So if we just wanted to find the area between these two curves, what would we do? Just let's set up the integrals.
Do the integral from 0.179
Uh-huh.
to 1.077 of 8x minus e to the 2x.
Okay, excellent. So like, and if we wanted to do it about the x-axis, if we want to do this about the x-axis, what would that how would you set up that volume?
Pi times the integral from 0.179.
We'll just call them A and B.
Yeah, okay.
Okay.
Of 8x squared minus e to the 2x squared.
8x20 squared. Okay, that's all right. So that's pretty good. We're gonna have to give you a harder one. What about if we want to do the same region about? How about let's do it about the y-axis?
Okay. Then y is it y over 8 for the 8x?
Right. X. Right. This one is going to be y over 8, and this one, how would we solve for that?
Take the natural log of y and divide it by 2.
So it's x is equal natural log of y divided by 2. Okay, that's good. So if we're going to revolve this around the y-axis, well, tell me what else we need to do.
You do the same thing except and square the different things and subtract them.
Right.
Right.
But the whole thing is, though, that the limits will be different, though.
Oh yeah.
Okay.
So
And what I did was I already figured them out. I just multiplied each one by 8 since it's 8x.
right.
So this one, I'm just going to call this C and D.
Okay.
And that, right, and so it's the same thing except that it's, which is the big R, which is the outside radius.
The natural log of y. over
Right,
2.
so, yeah, so you got this pretty, I thought you said you didn't understand this.
Well, not incredibly well.
Okay, we're going to do one more, we're going to do one more. Hey, Delbert, how many people we have waiting? Okay, we're going to have to, let's do this one. Let's rotate about the line. If you get this one, you're okay.
Okay.
About the line y equals -1.
Okay.
So,
So you take the pi times the integral from c to d, right?
well, actually, if we rotate about something about the x-axis.
Oh yeah. Okay. Then it's from 0.179 to
Right,
1.077.
right. If the x-axis are parallel to the x-axis, we'll use x points because it's going to be dx. And what's big R going to be? I'm just going to let you say it verbally.
It's gonna big R is gonna be. Irby says 8x plus 1. Is that right?
Yeah, because see, this is like 8x, and then you have to add
And then
1
one
to
more
this,
'cause you go
right?
down.
And then the little radius would be e to the 2x plus 1.
Plus 1. Okay.
You see that?
Uh-huh.
So, I mean, you just sort of, what I like to do is I like to draw a line from the line I rotate about to the actual curves, and that, I can see that this is 1 plus whatever that y value is.
Okay.
You know what I mean?
Yeah.
Well, that used to look like you're doing pretty good. And that was a great, great song. Thanks for doing that.
Oh, thanks.
Keep working hard, all right?
Okay.
Bye.
Bye.
Hey, Preeti?
Hi, Mr. Fleischer. How are you?
Preeti, I don't have a picture of you, but I do have a picture of, you know, somebody who looks a little bit like you. Do you want to see that? Do you want to see her? She goes to WTY. And I always think that you guys look alike. You guys have to introduce you. Doesn't that look like you a little bit?
No, that looks nothing like me.
I think it looks just like you.
I don't think so.
Okay. I think it looks just like you. But
right.
anyway, and so Kalita, you have to call in then, and I'll show a picture of Preeti.
Okay.
Preeti, what type of problem you want? A hard one? Okay.
No, actually, all right, you choose.
I choose. Okay, here you go. This is it now. Can I tell everybody what you're unhappy about?
Sure, go ahead.
I don't know. We'll have to ask the teachers out there. You know, I think that in order to earn 100 for the 6 weeks, I think you need to, like, not get it through extra credit. I think you need to get it on the test, and Preeti and I had a discussion about that. Anyways, let's do this problem.
All right. First, you set u equal to square root of x
Okay. Why do you know that already?
because it's the only e and
Right, if there's only one e, that's what we're going to set u equal to, the exponent. Very good for remembering that. That's good.
thanks. Dx equals du over x to the 3/2. right?
So du is equal to 1/2, wait, tell me what du is equal to?
I thought it was dx equals du over, I skipped that part.
Okay, so dx is equal
It's
to,
half x to the negative half.
okay, half x to the negative half. Okay,
So it'd be 1 over 2 square root of x. If you
So-
want to
so-
change that.
so du is equal to 1 over 2 square root of x, all right?
Uh-huh. And then,
So keep going.
all right, just a second. Can you multiply that so the square root of x is on the top?
You tell me what you want me to do.
Okay, all right. Just a second, Mr. Fleischer. Actually, put dx equals du
dx is equal to du, okay?
over, I'm going step by step, but
Okay.
over 1 over 2 square root of x. So
Over-
you can switch, you can,
Over 1 over?
Yeah.
Okay. And now
so
what do you want
it'll
me
be
to
the
do?
same thing as 2 square root of x.
So dx is equal to 2 square root of x
Yeah.
du, okay, good.
You put the integral and you put e to the u over square root of x.
So we got the integral of e to the u over square root of x,
Yeah, and then you put 2 square root of x.
okay, and then what do we do?
You can cancel out the square root of x,
Okay,
and then you can bring out the 2.
okay.
I can't see what you're doing.
All right, so so it's 2 over e to the u dx, all right?
Then you have
Or
the,
du, this is du, this is du,
yeah.
okay.
So you just, it's 2, e to the, integral of e to the u is just e to the u.
Okay, and then what do we do?
There's no limit.
So I know.
Oh, you plug it in a square root of x, 2 e to
Very
the
good,
square root of x
Preeti,
plus
very
c.
good.
Thanks, Mr. Fleischer.
Did
Did I get that right, or are you
Yes, you
gonna
did,
are you
yeah.
gonna deny that I didn't get it
You
right?
did get it right. Didn't you like Jane Lilly's voice?
Who?
Didn't you hear, you must have
Oh
just.
yeah, I did.
Wasn't that
I did.
great?
Yeah, it was very pretty.
Okay. Call in again.
All right.
I'll see you tomorrow morning. Jose Delgado?
Yeah.
What's going on?
Nothing much.
Science and engineering?
Yes.
Who is that?
Huh?
Who is that?
That was Kyle Reagan.
Kyle Reagan?
Yeah.
The great Kyle Reagan?
He's the bad Kyle Reagan.
He's the bad Kyle Reagan?
Yeah. He has 2 halves.
His 2 halves? You're the great Jose Delgado, right?
No, not really.
Okay. See if you can do this problem.
I can barely see it. Okay, hold on. Could you call it out?
Oh, you want me to call it out? Okay, x squared y plus 2y squared is equal to 4.
Okay.
Find dy dx at 1 comma square root of 2.
Okay. It's an implicit differentiation problem. And for the first part, you're going to have to use the product rule.
Okay?
So you're going to get x squared times dx, or dy dx,
Okay?
plus y times 2x,
Okay?
plus 4y dy dx
Is equal to?
is equal to 0.
Okay, what do you want to do now?
Take like terms over to one side.
Okay?
So you're going to get x squared dy dx plus 4y dy dx is equal to 2xy minus 2xy.
Okay, then what do we want to do?
Factor out of dy dx,
Okay?
and then divide by x squared plus 4y.
Okay?
So you're left with dy dx equals minus 2xy. What? Oh, okay. I'm kind of working it out here, so I'm a little bit
That's
behind
okay.
you. X 4y. And then you can plug in your values that they give you.
So let's do that. So we plug in 1 and square root of 2. You got negative 2 square root of 2. If you plug in 1 over 1 plus 4 square root of 2, right?
Yeah.
Okay, and what you could have also done what you could have done is, and it's great that you solved for dy dx, but you could have actually plugged in the numbers here.
Oh, yeah.
You could have plugged in there, but I like the fact that you solved for dy dx first. It makes a little more sense. All right?
Okay.
Hey, great job, Jose.
Okay.
Let's give him a hand. Which Jenny is this at WTY?
Jenny Geiling.
Jenny Geiling, how you doing?
Fine.
Is Jenny Vickery at softball practice?
Yeah.
You guys killed Hillcrest last week, you know that?
Oh, yeah.
It was,
of course. We're awesome.
I have to, by the way, Miss Harmon, I'm going to be there tomorrow afternoon, and remind me to tell her something about the softball thing.
Okay.
Okay. What type of problem you want?
A really easy one.
Okay. I don't know if I have really easy ones, but I do have an average value problem.
Okay.
So, let's try that one.
I forgot how to do average value. Okay.
What's the formula for average value?
Well, it's 1 over b minus a times the integral from a to b of secant squared x.
Okay, or in this case, it'd be secant. So it's 1 over pi over 4 minus 0 from 0 to pi over 4 of secant squared x. And what is the integral of secant squared x?
It's 1 over cosine. Oh, sine. Oh, it's tan x.
Excellent. So 1 over pi over 4, we could simplify 1 over pi over 4 to be 4 over pi.
Yeah.
So it's tangent x
From 0 to 4.
from 0 to pi over 4. And what's the tangent of pi over 4?
The tangent of pi over 4. It's 1.
Yeah, and what's the tangent of 0?
Tangent of 0 is 0.
See, you see how important it is? Like, you could do the calculus to know, like, the basic trig values and stuff like that. I mean,
Yeah.
and that's 0, so the answer is 4 over pi. So, like, you could do the calculus part, so, knowing those trig values are really important. You know Jenny Geiling?
Huh? Yeah.
Yeah. You
Oh,
do-
and Jake, Jake wants to talk to you really quick.
Okay. Hey,
Oh, I just wanted to tell you that there's a correction on one of the problems that you did earlier.
there is? Okay.
Yeah, I think it's the fourth problem, the one where you rotated about the x equals 4.
Okay.
Do you remember that one?
I think it was about y equals 4, wasn't it?
No, it was x equals 4.
Hold on. Correction.
Yeah, correction.
It's 4 minus x. All right. Where's the, okay, this one?
Yeah, that one. It's
what's-
actually two integrals because your square root of x plus 1, the y-intercept is 1. So can you redraw it?
Well, oh, I see. Oh, yeah, you're right. That doesn't, very good.
So there are two integrals.
You're right. This would be a pretty tough problem, right? There would be two separate integrals. You'd have to take.
One from 0 to 1 and then one from 1 to 1.618.
That's right. Hey, Jake, stop correcting me, Jake.
Okay.
All right. But yeah, he's absolutely right. When I was looking at the drawing, I guess that I didn't see it, but you're absolutely 100% right that from here to here it would be one integral, and then from 0 to 1 be another one. That is, hey, Jake. Stop correcting me.
Okay.
Hey, that's great. Thanks, Jake.
Bye.
Maurice Johnson.
Howdy, Mr. Fly.
Howdy. How you doing, Maurice?
I got another correction for you.
Another correction?
Yeah. It's the problem where y is equal to e to the 2x and y is equal to 8x.
Yeah, I don't think there was a problem on that one,
Yes,
was there?
there is, and you rotate around the x-axis, I believe.
Are you sure about this?
Yes, sir.
You're 100% sure?
100%.
All right. Want to rotate about the x-axis?
All right. You see where it says let R be the region enclosed by y is equal to e to the 2x and y is equal to 8x?
Yeah.
And y and the y-axis?
Oh.
See, you solved for the wrong area.
Yeah, you're right. I didn't. It's a good thing they don't pay me.
Editing behind the fact.
It's a good thing they don't pay me.
Yeah. Okay.
You're right. Yeah. I matter of fact, is there a boundary by that region? Was that whole question?
Yeah, it's a little triangular region.
Yeah, there sure is in there. Well, you know what? That's what we're trying to do. We're trying to make
1 day, Doc. 2 in 1 day, Mr. Fly.
I know.
You're
Two.
slipping here.
It's actually, Maurice. It's actually 2 in 6 years.
Oh.
This is the only two mistakes I've made. You know what it is? It's the white shirt. I'm not supposed to wear white. It's blinding me. No, that's you're right. That's I didn't do the correct problem. But thanks And stop correcting me, you and Jake. Okay,
Okay.
hey,
How about a cross-sectional?
a cross-sectional one? Hey, you know what? Let's do that region, your favorite region that you're correcting me on. So now, you're right. I didn't do the y-axis. I just did it where it's bounded by the two of them. So, yeah, that's a little tiny region down there, isn't it? Yeah, see, what we did, well, let's actually show the calculus viewer. What we were doing was we did the region bounded by the two curves, but actually we really wanted to do this tiny region down here. That's by the y-axis, the line, and the curve, right? Right, Maurice?
Yes, sir.
You see that little tiny thing down there? So let's adjust the window a little bit so we can see that. How about 0.5? How about 0.5? Let's see if that's enough. There's the, oh, it wouldn't be 0.5, it'd be 1, wouldn't it? We'd have to make that 1. We'll make it 2. There's the line, and there's the curve. So we're talking about this region right here, right?
Curves on.
And what's the point of the point of intersection would be 0.179, right?
Yes, sir.
Okay, that's great. So what is the, let's answer this question there. So that's 0.179.
Okay.
What is the, hey, if you just had to find the area of that region, what would it be? You just had to find the area of it.
It would be the integral from 0 to 0.179
Uh-huh.
of e to the 2x minus 8x.
Okay, it's easy enough, right? Do that in the calculator.
Okay.
What about if each cross-section is squares?
Square the quantity.
Square the quantity. What about if they were semicircles?
If they were semicircles, you would divide that quantity by 2 and then square the whole thing.
No, it would just be,
And then
wait, hold on.
multiply the integral by pi over 2.
Okay, semicircles, I'm glad I could correct you because that would be embarrassing. It's semicircles are this. You just square the whole quantity and multiply by 1 over 8 pi. He said divided by 2. I heard him say divided by 2. Let's roll the tape back.
Well, you're supposed to, but you could have brought the 1/2 out. With the,
I don't know. We're going to have to replay that to make sure. This would be equilateral triangles. And then that's equilateral triangles. And then isosceles right triangles would just simply be this.
What is 2 squared?
4.
Okay, so wouldn't that one we're talking about the semicircle be 1 over 4?
And then divide by 2 and multiply it by pi. Did you say that, Maurice?
Yeah.
All right, then you're absolutely 100% right. So,
All
but
right.
so all these formulas, as figuring out through geometry, it's pretty. I mean, once it's pretty easy, but it's the same thing every time. It's whatever you find the area, you square the area, and then multiply it by these quantities out here, right?
Right.
It's actually
Thank you, Mr. Fly.
It's actually pretty easy to do. Hey, Maurice.
Yeah.
Fine job, Maurice.
You too.
Who's the? Hey, Jermaine, what's going on?
Hey, Mr. Fleischer, how you doing?
Pretty good. How you doing?
I'm all right. Let me get a problem on volume, sir.
All right, I was just about to get you one on volume. Let's do the same region, the region that I messed up on.
Okay.
Where'd it go?
Who's Giovanni?
Okay. All right, here you go. The same region, Maurice. You're going to get pink, a pink paper.
Thank you.
The same region. Now, we're redoing the region. 8x is this, and e to the 2x is equal to that. So, and this was 0.179, and we want to rotate this about the line, y equals -1. So, if that's y equals -1, first of all, Maurice, we'll do it our way. Is there a hole or no hole?
There's a hole.
There's a hole. So what's the formula?
The formula is going to be r pi times r squared minus little r squared.
Okay, is it dy or dx?
Dx.
Okay, so we're going to go from 0 to 0.179. Okay, now here you go, Jermaine. How do you find the big R?
Big R is going to be the, you draw a line or lines from the straight up all the way to the inside. Yeah, there we go.
Okay.
And that's going to be your big R, which is going to be e to the 2x.
It's e to the 2x
Plus
plus,
1.
plus 1, right. So it's pretty easy, right? E to the 2x plus 1, excellent. And then 0 to 0.179, and then what's your little r going to be?
Little r is going to be 8x plus
8x plus what?
plus 1.
Right.
Yeah, plus 1.
Isn't that easy, Jermaine?
Yep,
Yeah,
very easy.
this stuff is no problem, right?
That's right.
Hey, great job, Jermaine.
Thank you.
All right, calling again. Chris Young,
Yeah,
how you doing?
doing fine.
Okay, here you go.
Oh boy.
H of x is equal f of g of x. Find h prime of 2 if you have all that stuff.
Okay, if h of x is equal to f of g of x, then
What's h prime of x equal to?
h prime of x would be equal to the f prime of g of x times the derivative of gx, g
Excellent.
of x.
Excellent, excellent, excellent. Okay, now what do we do?
Okay, since we're given g of x and the derivatives of the two, so that means we can. Okay, so we could plug
What does
in
h prime
g-
of 2 equal?
Huh?
What does h prime of 2 equal?
H prime of 2 equals the f prime of g of 2 times the g prime of 2.
Okay, now what g of 2 is equal to 3, so it's f prime of 3
F prime of
times g prime of 2, right?
3. Yeah.
What's the answer to that?
Okay, so the f prime of 3 equals 2, and the g prime of 2 equals 5, so it's 10.
Chris, that is too easy for you, man. Too easy. That's a good job. You remember this? This is the chain rule, right?
It's chain rule, yes.
That's right. Chain, chain, chain. Hey, Chris, call in again. That's a great job.
Thanks, bye.
Preeti, what are you doing?
Mr. Fleischer, I'm trying to get points as much as I can.
I'll tell you. I'll tell you.
Wait, before you
now I have
give me
to give you a hard problem.
No, wait. Before you give me a problem, is it okay if I can get points, like if I call twice?
No, no.
That's not a rule? Well, can I hang up then?
No. Hey, this isn't that bad. This isn't that bad.
Okay.
All right. It's probably too easy for you. I don't even know if I should give you points for this.
Oh, man. All right. I guess you set the, no. See, I'm not sure. If there's an E up there, do you do the second fundamental thing?
No, that's not a variable.
Okay.
And I'm not
so I
asking
guess
for
you
the
don't.
derivative of it.
Do you set the top equal to u?
What?
Do you set the top equal to u, the numerator?
Nope.
You don't?
Nope.
Oh, wait, it's like you factor it. You factor the top.
Okay, then do it.
All right. X plus 2.
X plus 2?
Yeah. No, wait, x minus 2 and x minus 2.
No, that doesn't factor out. What you want to do is you want to rewrite it like this. I'm going to give you a hint.
Rewrite it.
The x over x plus, let me write it neatly, x squared over x plus x over x plus 4 over x. Because that's what
Okay.
this is.
Yeah, you're right. I always have...
I'm glad, at least I've been right once. X plus 1 plus 4 over x.
Okay.
Okay, what's the integral of that?
It's 1... No, wait, it's not 1. X squared plus x,
What's the integral of x?
half x squared over squared, so half x to the x squared.
Okay, 1/2 x squared,
Yeah,
all right.
there you go. Plus x. That would be 4 over x to the 2.
What's the integral of 4 over x?
X to the negative 1.
Okay, if it's 4x and
Oh,
negative...
negative 4x, okay, negative 4 over x to the 2.
When you add 1 to negative 1, what do you get?
When you add 1, I don't get it. I thought you just multiply 4 times negative.
When you integrate, don't we add 1 to the exponent?
Oh, that's right. I'm doing derivatives. Never mind.
So what's the integral of 4 over x, or 4x to the negative 1?
There's just a 0, so if you add 1, there's just 0, so it's just 4x, right?
Over 0, and we got a problem with that.
Yes, we do.
So what's the integral of 4 over x?
Not sure.
How about 4 natural log of x?
Okay, that's right.
Does that look familiar
Yeah,
at all?
that looks familiar. All right, you're
Okay.
right.
Preeti, I may take off that point that you earned earlier.
Okay. No, you can't do that. It's not connected.
I'm just kidding. Come on. What do we do from there?
You plug in E, and you minus.
Okay, so it's plus e plus 4 natural log of e
Yeah.
minus 1/2 plus 1 plus 4 natural log of 1. Okay? What's 4 natural log of 1?
0.
What's 4 natural log of e?
Natural log of E to the 4. So it's
What's natural log of e equal to?
natural log of E is just
Is
E to
it-
the
is
0
this-
is just 1. 4.
It's just 1. So
It's
therefore,
4 plus 4.
so the answer is 1/2 e squared plus e plus 4 minus 3/2, and you could simplify that to be plus 5/2. So
Okay.
it's 1/2 e squared. You see that?
Yeah,
Take a look at that, Preeti, okay?
all right.
We'll talk about it in the morning.
Okay.
Okay, who's next? Steven?
Yeah,
Which Steven?
Stephen
Stanley? How you doing, Stephen Stanley?
I'm doing okay.
I'm glad you're doing okay. That's good to hear. What type of problem you want?
Can we work on a differentiable equation?
Differentiable equation. I can make one up for you. Okay, here we go. How about dw dt is equal to 2w t squared. Find w if when t is equal to 3, w is equal to 1. Find w in terms of t.
Alright. So first you'd get the W's on one side and the T's on one side.
Okay.
So you divide the 2W to get dW over T. Oh, yeah, just divide the W.
Just divide the w, okay.
And then you multiply the dt.
So we got 2t squared dt. Now what do we do?
You find the integrate, so the dw over w, that'd be natural log w.
Uh-huh.
And over on the dt side, that'd be 2 t to the third power over 3.
Okay, plus c.
Yeah, plus c.
Okay, now what do we do?
You e it.
Well, do you want to solve for, we could solve for c first if you want. I mean, you want to e it? Okay, we'll eat it.
Alright.
So w is equal to e to the 2t cubed over 3 plus c.
Put the c in front.
Okay, because e to that times e to c, so w is equal to c e to the 2t over 3 to the third. Now what do we do?
You find the c
How do we do that?
through equations.
What?
Alright. Well, if you move the picture, yeah. So, plug in the t, or the 3 for t.
Mm-hmm.
So that'd be 6 cubed.
3 cubed is 27 over 3 is 9.
So that'd be 27 times 2
Well, it's 27
over 3.
Okay, or 27 over 3, which is 9 times 2. It's
Okay,
18.
so
That's a
it's
little
18.
easier. So 1 is equal c e to the 18th.
And then you find the e to the 18th.
So what is c equal to?
Oh, get the c onto the other side.
Okay.
Or 1 over e to the 18th.
So then the final answer is w is equal 1 over e to the 18th times e to the 2t cubed over 3, right?
Yeah.
Hey, great job, Stephen Stanley.
Thank you.
Okay. Quentin Neely,
Yeah.
Carter Cowboys,
Yes, sir.
what's going on?
Miss Branch wanted to get you to get her shout out.
Is she there?
Yeah, she's here today.
I'd like to give a shout out to Ms. Branch at Carter High School. You know, it was a lot better when it wasn't forced. How you guys doing over there?
All right.
Okay. Hey, let's give you this problem right here. This is going to be a calculator problem. Find f of x is equal to natural log of 3x cubed plus 1. For what value of x is the slope of the line tangent to f at x, f of x, equal to 3?
Okay, for this, you have to find a derivative.
Okay, that's good. So what does f prime equal?
1 over the quantity 3x cubed plus 1.
Okay.
And then you set that equal to...
What else do we have to do? The derivative natural log of u is 1 over u times what?
1 over u times u prime.
Okay, and what's u prime?
U prime is, let's see, 9x squared.
Very good, 9x squared. Okay, now what are we going to do?
Then you're going to plug in 3.
Okay, be careful now. If we were going to plug in 3, what that would
Oh,
be,
it's equal to 3. I'm sorry. You set that equal to 3.
right, if we were going to plug in 3, that would tell us what the slope is when x is equal to 3. But we want to know when at what value for x does the slope equal 3.
Right.
Okay, now you got 9x squared is equal to 9x cubed plus 3.
Right.
Now, how would you solve this if you have a calculator? What would you do?
Move it over and
Move it over, so you got 9x cubed plus 3 minus 9x squared. And now what do you want to do?
you want to put it in y sub 1.
Okay, y sub 1, and then what are you going to do when you get to y sub 1? What are you going to look for?
Yeah, zeros.
Look for where it crosses the x-axis, right?
Right. Right.
Excellent job. Excellent job. We're not going to do that. We're going to try to get one more call in, okay?
Okay.
Hey, Quentin, great job.
Thanks.
All right, keep up the good work. Scott Hill or Scott Kittner?
Kittner.
Scott Kittner. Okay, here you go. We got like 2 minutes left.
Something easy I can do.
I don't have anything easy left.
Ah.
Okay, here we go. If f of x is equal to the integral from -1 to x squared root of 1 plus t, what's f of -1 equal to? We got to do all these.
What's the top limit?
X. -1 to x. And what's f of -1 equal to?
Is that where you...
F of -1 would be the integral from -1 to -1.
Yeah.
And what does that equal?
Square root of 2.
The integral, if these are the same, what's the answer going to be?
I can't see, I'm sorry.
What's if these are the same? If the bottom is -1 and
No,
the
0, no area.
it's 0, right?
Yeah.
Okay. What about f of 1? How would you go about figuring this out? The integral from -1 to 1. What would you do to figure this out? Just tell me the steps.
You'd integrate, and then you'd plug in 1 and subtract -1.
You would. How would you integrate it?
Is it 1 plus t? Square root of 1 plus t?
Right. We could do this in the calculator. If not, it would be 2/3 times 1 plus t to the 3/2.
Mm-hmm.
Okay. What about f prime of 1? How would you find f? What's f prime of x?
F prime, it's square root of 1 plus t.
What is it?
Square root of 1 plus t.
Square root of 1 plus x.
Oh, x, sorry.
And so f prime of 1, it would just be square root of 2.
Yep.
Okay. What about f double prime of 1? How would you find, what would be f double prime of x?
Take the derivative of square root of 1 plus x.
Which is what?
It's like 1/2 times 1 plus x. Times derivative of what's inside is 1.
To the -1.
Yeah.
Okay, Scott, we'll see you in the morning. We're running out of time. Y'all keep working hard. We got 4 weeks left. Best of luck. See ya.